Okay, hello. It's amazing to be here. Thanks for joining to this talk, IoT Scenarios with Azure IoT Edge. I have to confess it's a rather bulky title, right? The reason is, back then in January, I guess, when I submitted this talk for this conference, I had absolutely no idea how far Microsoft will be with Azure IoT Edge. So therefore, I've chosen this rather bulky title to have a kind of a backdoor. Yeah? If there is nothing to present, nothing to talk with, I would come with some marketing slides and talk about scenarios. But the conference is called WeAreDevelopers, right? So I guess developers prefer to see something in action instead of marketing slides. Am I right? Yeah. Okay. Fortunately, a lot of things happened in the meantime in the last 3 months, and good news is there is a lot to show. And therefore, just to set the expectations right, I'll change the title of my talk, if you don't mind, to just Azure IoT Edge, okay? I will cover scenarios, but to be honest, it's just they all fit onto one slide, okay? So, and before we do a deep dive into Edge, I will spend a few minutes about just IoT, Azure IoT in the cloud, and then we move and see the difference to the Edge, okay? First, I will start to introduce a rather cool piece of hardware, yeah? This one is called the Microsoft Azure IoT Dev Kit. Microsoft is shipping this since the beginning of this year, I guess. I love this piece of hardware. It's an Arduino-compatible board, but it comes with a few sensors already built in on the board. For example, there is an accelerometer, humidity, temperature, a couple of buttons, pressure, even a microphone, and even a display sits on top of this device. Reason for this is Microsoft wants to make it very easy for developers to start with IoT. Yeah? And maybe wiring up sensors and do soldering might be a bit of a hurdle for some developers. Personally, I think it's fun, but okay. And to make it easy, they are shipping this. It's also available in Europe. Nice piece of hardware. And for a presentation, for some samples, I could just use the temperature sensor and send it to the cloud. But to be honest, the temperature feels somehow like the hello world of IoT, right? So I was thinking of something a little bit more cool. Yeah? And then I went into my children's room, in the room of my kids, and came out with something with a Stirling engine. So, don't mix it up. It's not a steam engine. It's a Stirling engine. This invention is about 200 years old. And if you're interested in how it works, go check out Wikipedia article. Maybe you ask yourself, why the heck has a 12-year-old boy a Stirling engine in his room? Actually, it was a Christmas present. In fact, he was asking for a Sony PlayStation. I understood Stirling engine. Anyway, sorry, boy. Okay, so, and for me, this is a symbol for the Industrial Revolution. Yeah? And I'd like to combine that with the other buzzword, Industry 4.0, okay? So I thought I'd just put a few sensors around, and again, I had to walk into my kids' room and came out with some Matador, some toys. Did you play in your childhood with that as well? Cool. And I put some sensors with rubber band on it. Here, I'm using a Hall sensor, or let me switch to the camera. I have a camera here. There you go. So here there's a Hall sensor that detects magnetic fields. Therefore, on the wheel, on this flying wheel, I also put a magnet here, and this sensor is just counting for the revolution, round per minute. Here, there's a flame. Hi, Daniel. Thanks for joining. Here we have a fire detector, and there's also a temperature sensor that works without contact on a small distance via infrared. Okay, and yep, put all things together and wrote a small program. It's called a sketch, and yeah, deployed it on this device. So then the question is how to connect external sensors with this device. And fortunately, maybe you have seen so golden connecting fingers. And those are microbit compatible. I don't know if you have ever heard of microbit. Microbit was developed by BBC. And all kids in the United Kingdom get one device to educate them doing programming. Unfortunately, here in Austria, we are a few years behind, and so it needs some private initiatives to educate kids for computer programming stuff. And I would like to promote one of those private initiatives. It's called Coder Dojo. It's an event that happens all over the world, I guess, at least in Europe. Here in Austria, we have 3 locations. Started all in Linz, now there's one in Horn, and of course, one in beautiful Vienna. So we meet every 2 weeks and invite kids starting at the age of 7. And this Coder Dojo has a booth here in the 2nd floor, I guess. So I'm happy if you stop by and bring your kids next time, or even support us as a mentor. Yeah, I think it's a very important and funny thing. Okay, so these connecting fingers are compatible to the very popular microbit device, and that means I can use all the extensions that are already available for the microbit. They will work with this IoT Dev Kit as well. So I used one of those connectors and wired everything, so therefore, yeah, I could connect and wire up the sensor easily. Okay, so let's see that in action, okay? What do we expect? We want to send data, temperature, revolution, up to the cloud. Yeah? There is a service in Azure called IoT Hub, and we're sending data right to this IoT Hub. And even better, it's also possible the other way around. I can even send from the cloud messages and even invoke methods on the device. Here I implemented 2 methods, a start and stop method. I can invoke those from the cloud. Let me start with that. So go to the portal. Here I have an overview of my available IoT, can you read everything? Yeah, of my IoT hubs. Select this one. There you go. Here there's a section for IoT devices. And you will see here there's already one registered device, which in fact is here this Stirling Engine stuff. Okay, drill down here and let me share the screen, split the screen here, and I will send a message here right from the portal. Yeah? The message is, what else? We are developers. Send message, and hopefully, if the demo gods are with me, yeah, there you go. It's hard to read, but here on the display, you see we are developers. Okay? So I could now call the start method. I will do that, but not from the portal. I'll switch to another tool, Visual Studio Code. Here, if I refresh here, I have access to all the devices and edge devices here in my IoT Hub. That's thanks to an extension of Visual Studio Code. Yeah, I installed that extension, and that gives me all those capabilities here. And I will here invoke directly a method, and the method is called start. Enter, no payload. Okay, invoking. There you go. And immediately we are sending the revolution round per minute, the temperature, and the status fire. Ha! Too bad. it tells me true. Do you know why? There are some reflections in the infrared spectrum, so therefore it indicates true. If I try to shim that a bit, no, it doesn't work, sorry. So this indicator is wrong. But anyway, I hope the temperature, 29 degree, revolution currently 0, but let's change that. Go to the camera, make it full size. Now the fun begins. So let's put some fire here. Change here the view. So, okay. Currently temperature is 50. Maybe that's already enough to start the engine. There you go. And let's have a look here. Yeah, round per minute, 700, 800, 900, 1,000 and more. Okay, fortunately the first demo worked. Okay, so yeah, IoT in the cloud. That's available, not ever since, but a couple of years, nothing so new. So there we go. Okay. We watched data in the cloud. We have seen a bit of management, right? We sent messages, invoked a method. And you can imagine that thanks to the power of the cloud, you can do a lot of things. You can use that power to train machine learning and do other advanced things in the cloud. So why do we need something else? Why do we need something on the edge? Well, for a couple of reasons. And now this is the slide with the scenarios, right? For example, imagine that I want to control the way the machine works. For example, to control the speed by increasing or decreasing the temperature. Okay, so that would mean a tight control loop. Maybe it's not the best idea to have that calculation in the cloud. I guess it's way better to bring that as close as possible in the factory, of the machine. Okay. That would be the first reason, if you need real-time response and low latency for those control loops. Another scenario would be if you want to pre-process your data. Microsoft did an amazing showcase at the Build conference in Seattle last week, where they did image recognition. And yeah, I guess it's obvious that if you need to transfer data of a video stream or many video streams, it would cost way too much bandwidth, right? So it's a perfect scenario where you would do this pre-processing on the edge. And also other intelligence on the edge, like machine learning, AI, or other complex analytics of live streaming data in almost near real time. Okay? Offline operations might also be a very useful scenario for you, either short-term or even long-term. For example, I work together, I'm involved in a couple of IoT projects with Tieto, and one of our client showcases is machines that work most of the time underground, so they're most of the time disconnected, even for a longer time span of weeks. But when they're connected, we want to have the data in the cloud for further data analysis. Maybe in your factory you have a couple of machine sensors that speak different protocols, so protocol translation and normalization would also be a perfect use case for edge computing. And last but not least, privacy. Maybe you want to protect your intellectual property and prefer operation on-prem instead of everything in the cloud. Okay, and what's interesting is, interesting with Microsoft's approach of edge computing is they try to make the experience as consistent as possible, especially for the programming model. Everything that runs in the cloud already should also work on the edge. Makes sense, right? So, and the way to achieve that is by following a couple of concepts. The first concept is modules. For on those edge devices, we will have a couple of functionalities, right? And all are split into separate modules. Let's call those unit of compute. Those modules are in fact packages, containers, Docker containers. I bet in the meantime everyone here has heard about Docker. We will isolate all the logic, the functionality in a Docker container and publish it somehow to an edge device, okay? These Docker images can be from, for example, Microsoft or any other third-party vendor, or you develop your own modules. There are a couple of SDKs out there already. You can do that either in C#, in C, Java, Node.js, and for the cool kids, Python. Yep, and pretty soon it will be also available to browse the Azure Marketplace for already existing Azure modules. And of course, it will also be possible that you submit your own modules there on the Marketplace and try to monetize those. Okay? Next concept is we need a kind of a runtime. Yeah? We have a piece of hardware, and yep, there we need to deploy certain whatever. It will also be, and again, a package, a Docker package, the agent, and this one will be then responsible for a couple of things. It will cover all the security stuff. It will guarantee that the other modules are up and running. And yeah, of course, it also reports the health state. And most importantly, it is responsible for the communication. Communication between leaf devices, any hardware that talks to the edge device. It is responsible for the communication among the different modules. And of course, it is also responsible for the communication of the edge device itself when it talks to the cloud, to an IoT hub. Makes sense. The third concept is routing. You need to define how the data flows between all those modules. Yeah? And there is an easy query syntax where you define, it reads a little bit like SQL, from anywhere from a source, you have a where condition, and then you define an into a sink. Okay? So this example here tells us, okay, take the output of module 1, this one, and use that as an input in this module 2. Also apply a where condition only with sensor type equals temperature. Yep. And if you want to send data directly to your IoT hub, then you always have the dollar upstream available. That's just the IoT hub in the cloud. Okay? Last concept is device management. So that works using a so-called device twin. Device twin sounds complicated, but it's nothing else than a JSON document. In fact, 2 JSON documents, because one lives in the cloud and the other resides on the edge device. That's why it's called twin. And this JSON document has a couple of sections. One, maybe the most important section is the desired properties. So this is controlled in the cloud. Yeah? Here, for the desired properties, you define all parameters. That's owned, controlled in the cloud. On the other hand, there's the reported values section. That's controlled on the other twin, on the edge device, and that reports the current values to the cloud, so that they become available in the cloud as well. Also interesting is the tags section, so you can use whatever tags you want, and very interesting option, so you can query in the cloud, hey, give me all edge devices that are in Vienna or of a certain factory type or whatever. You can structure those tags as you want. And finally, you could also define methods, so it's pretty much the same like we've seen for the regular IoT devices when I invoke the methods. Okay, so then you might ask, what is the hardware requirement for that? Here in this box, let me show that on camera as well. There you go. So move the camera. Okay, what you see here we have an industrial PC, right? And here is just a Wi-Fi router access point that is connected through LTE to the internet, okay? That's more or less everything what's in this box, okay? But the minimum hardware requirement is way lower. It starts already with a Raspberry Pi 3. It can be anything that runs Docker, can be Linux, can be Windows machine, yeah, as long as it hosts Docker, so it's cross-platform. And as I just mentioned, we're using here an ordinary industry PC, but it really depends on your workload, on the things you want to calculate, you want to analyze, you want to do on the edge, on premise. So maybe you end up with larger devices, more compute power, but yeah, as I just told you, it really starts very low with a Raspberry Pi. Okay, let's see that in action. May the demo gods be with me. Switch again to the portal, to the same IoT Hub. Okay, that one. And here I changed to a different section. Here you see IoT Edge. It's still in preview. Let's go here, and I will create, from scratch, a new IoT device. I will call that WeAreDevelopers, okay? Save that. There you go, already created. And I'll switch into the details to copy the connection string. Okay, now I do a connection that's wired to this Linux Ubuntu machine using PuTTY. Okay, disconnected, so let me connect once again to this IP address. Sudo. Okay, and just check the Docker. List all the available containers. You see, okay, Docker is installed, but nothing else. So no image available, no container up and running yet. So I call the command IoT Edge control CTL, do a setup with a connection string of. The connection string is in my clipboard. There you go. And also call the parameter no pass enter. So now it's provisioning the device. The certificate is created, and within minutes, no, within seconds, it is deployed, and just need to start IoT Edge CTL start. That one, and let's. Oh, battery is empty here. Docker PS. So, okay, we have the first Docker container here. This agent, we deployed now the runtime on that device. Okay. If I switch here again to Visual Studio Code, I like that one. Do a refresh here. We see already in the cloud, even though we deployed it here on-prem, on the edge, it's already. Let me clear that. It's already deployed here, and yeah, up and running, the agent is already running. Oh, and let me disconnect that one because it still sends messages and I don't want to clutter up things here. Okay, we have an empty edge device that runs well but doing nothing. So let me deploy our first module there. I decided that my edge device should act as a Modbus server. And again, I will use as a slave device, again, this IoT Edge thing. That runs a small sketch that sends data, just humidity and temperature at that time. We know that it could be more fancy, but okay, anyway. So let me power that with a power bank. It connects to this Wi-Fi. I need a few seconds. Okay, I got an IP address. Okay, this is already available. So, okay, I told you I wanted that this acts as a Modbus server. So I need to deploy a module. Fortunately, I didn't have to write it on my own. It's already available on Docker Hub, provided by Microsoft. So I switch to the portal. Go to the set module section and say, okay, I want to deploy a new IoT Edge module. That will be called Modbus. And the image URI is, it's wrong, this is the image URI on Docker Hub is that one, copy, paste, image URI. And I also need to set some desired properties. So I will also copy those from this document. In this desired properties, we see a publish interval, we see the IP address of my slave, all the default configuration that's needed for Modbus, a start address, a display name, a specific polling interval, and every 2 seconds for the temperature, every 3 seconds for humidity. So let's just grab that piece of code, this JSON document, copy paste here, say save, okay, next. And now we see a default route. Let me zoom in here a bit. Okay, this is the default route. From star, take everything, every data, and send it to the cloud, $upstream. That's all the magic here. Yeah. So next. And then there's the submit button. And yeah, here already we see this new Modbus module already pending deployment. Let me refresh it, maybe still pending. So switch here to Visual Studio Code, refresh, okay. It's not green yet, it's still pending, but pretty soon it should be also available in green. There you go. Okay, so hopefully in a few seconds, I'm not sure. Yeah, there you go. Now we're receiving data from this slave device that is now connected over Wi-Fi to my box. Yeah? And the Modbus server receives the data and now is sending it directly to the Azure data center, and we get the data here live from Amsterdam, which is the data center I selected here. Okay, that demo worked as well, but to be honest, it didn't add very much value, right? We're just, again, having data, and the edge device here acts just like a proxy, nothing else. So what should we do now? I guess we should do some calculation, some processing, data processing on the edge device, yeah, to make this sample a little bit more useful. And I already talked about the consistency. Yeah, there is already a service available called Stream Analytics. Stream Analytics jobs are there to analyze large data streams. Yeah? This is a service that's already available for a couple of years, and this one should and will work in exactly the same way it already works in the cloud, will also work now on the edge device. So again, I go into the portal, reload, okay, and I'm landing here in the overview of my Stream Analytics queries. So here's one I already prepared, Stream Analytics temperature. I defined an input temperature, an output average, and here is the query. Let's have a look into that. This query is, okay, from my temperature input, define a timestamp with source timestamp, do aware, just I'm interested only in the temperature, not in the humidity, which is this address. And the power of Stream Analytics is that it comes with a couple of windowing functions. Yeah? I took here, for this sample, the tumbling window, which is nothing else but a stack of different windows here of the duration of 30 seconds. Yeah? And every 30-second window, I'm calculating here now the average, as average temperature, and also take the latest timestamp of that window, and put everything into output average. Okay? Back here to my IoT Hub, again to the set modules, and I say import one already existing Stream Analytics job, already pre-selected because it's the only one for an edge device. I also need to define a storage account, edge, that one, save. And the Stream Analytics job will now be deployed here. One thing I need to do, I need to change and next, and adapt the route here. Instead of this default route, my routing will be a little bit more complex. So here I define how the data will flow through my modules. Oops. There you go. There you go. So that means from my Modbus server module, take the output and send that to the Stream Analytics query to the inputs with the name temperature. Okay? Second route, the output of the same Stream Analytics query, which will be the average calculation every 30 seconds, should go to the $upstream, which is our IoT Hub. There you go. Say next, submit. Wait a couple of seconds. So, okay, pending deployment. Again, I will switch to Visual Studio Code. And hopefully, after 30 seconds, let me refresh here. As long as the internet connection here, LTE connection here is reliable, it should work. There you go. Okay, I don't know why it doesn't show up here in this extension window, but what we can see here, now we have it. What you can see here is we get the average temperature. You need to divide it by 100, so it's 28.28. I could do that in the Stream Analytics query as well, of course. But every 30 seconds, we get now a pre-processed piece of information, pre-processed on the edge device, now sent up to the cloud. Whew. Happy that it worked. Okay, and there, you can imagine that you can do all kind of things. For example, then in the cloud, for example, here there's another Stream Analytics job called average to Cosmos DB. So it's a very simple one. That one is now running in the cloud, not on the edge device. Yeah? It just says, hey, star everything, put it directly into Cosmos DB, which is the NoSQL database in Azure. Yeah? A platform as a service thing. So move here to our Cosmos DB. Open the Data Explorer. Select the one collection here. need to change here the filter. I will order it by timestamp, descending, so that the last document appears on top. Okay, apply. And so we see here, this is the latest document here. So make things a little bit closer. Okay, so every 30 seconds here, we will receive a new document, pre-processed data on the edge device, going to my IoT Hub, where the next stream analytics query kicks in and transfers then the data directly here to my Cosmos DB. So refresh and yeah, see a next document already available here. Well, in my slide deck, I have a couple of more links for you. So I really recommend all the IoT sessions from Bill from last week. Here I have 2 links, especially for the overview talk and the IoT Edge talk, which goes way more into detail. I could not, for time constraints, couldn't cover everything here. But if you're interested in security stuff, for example, or DevOps integration of modules, go and watch this video on demand. And if you're interested in this IoT Dev Kit things, I also put 2 links into my slide deck because I really love those. They are so fun and easy to work with. Yeah, and also very robust. Last but not least, if you're interested in IoT in general, there is an open hack event organized by Microsoft in 2 weeks in Zurich. So if you're this typical developer guy who likes challenge-based hacking for 3 days, I heard yesterday that there's still a few spaces available. This event is free. You just need to cover your own travel expenses, so that's all. With that, I'm in time. Even if you have some questions, then come in front to me and I'm always interested in discussing new ideas. So yeah, thanks for coming. Hope it was informative and a little bit entertaining as well. Yeah. Thank you.
Big applause.